This is the very last one, question number 19 on Module 7 homework. Test the claim below about the mean of the differences for a population pair data at the level of significance alpha. For these, they usually give us data, but they gave us summary actually. They gave us the d-bar, the standard deviation, and the sample size. So, I've been usually doing this, using the paired. But if you want to use the paired in StatCrunch, I'll show you real quick. They are going to automatically assume that we have data. Okay, so if you click on stat t stat paired, and that's the right test that we should be using, it's just that we don't know the original sample. So, we're going to have to do this just to use a slightly different method. It is still paired test, but because what they gave us is the summary of the differences, we can still do this using t-stat and just one sample, okay? Because they gave us, what they gave us is the sample mean and the standard deviation from the differences. So you can do this using t-stat and just go with one sample, and we have summary. So I'll show you how we can do this. The sample mean, the differences, the average of these differences were 1.3. And you know why I opened up t-stat, right? Because what they have for us is the sample standard deviation. That's not, there's little lowercase sigmas of d. This is the standard deviation of differences in the sample of this 19 data. Okay, so standard deviation is 3.2 and sample size is 19. And what are we assuming? That we're assuming, well, the alternative first is that the mu's of d, the differences, is less than 0. The alternative is assuming that it is, the null is assuming that it is greater than or equal to 0. So that's really all we need. So I have my numbers there. I just need to enter these, define this hypothesis for them. So the alternative is assuming that it is less than 0. So which one is saying that? All right, there. And it has to be alternative. Why? Because it is less than 0. It is strictly less than 0. It's not saying less than or equal to. If it has less than or equal to, that could have been a null hypothesis. But if it's just less than or greater than, it does not equal to 0, that makes it a null alternative hypothesis. The null is just the opposite of that. So greater than or equal to 0. That's the hypothesis. All right, so what's the standardized test statistic T? And the p-value, horribly big, right? That's way too big. Hold on. They want the critical value method. They do not want p-value method. Okay. So what I need is I need to open up my t calculator. I need to look up the t distribution. And what is the degrees of freedom? It's always one less than the sample size, right? Sample size is 19. So degrees of freedom is 18. But I'm going to have to open this up in, you know what, this is actually fine. Because if you look at the alternative, this is left tail test. Mu's of t is less than 0. So we want the area to the left of this specific critical value to be 0.05. So tell them, leave that blank. Tell them that you want 0.05 to the left of this point, okay? If you click on compute, ta-da, that's it. That's the critical value. So, round to what decimal place? 2 decimal place. I gave them an answer that was way too specific, I guess. Okay, so let's compare. So the critical value is this, and the rejection region is if it falls in this red area. But look, 1.75 is not less than negative 1.73. It's like up here somewhere. That's perfectly normal. So since the test statistic is not in the rejection region, we failed to reject the null hypothesis. Okay? There is not statistically significant evidence to support the claim. And that is how you can do, yay, this is the last one, I'm done. So that was question number 19 on Module 7 homework.